Hi, everyone. My name is Tim White, and I'm a fisheries scientist at Global Fishing Watch, which is a nonprofit that tracks global fisheries using remote sensing and machine learning. This is obviously a recording, so thank you for bearing with me. And if you have any questions, please feel free to email me at this address here, which is timwhite@globalfishingwatch.org. Today, I'll be talking about how and why we track fish and industrial fisheries for conservation and management purposes. I bet many of us are familiar with how and why we track fish in our oceans. So this is me trying to bring in a very big white shark to our boat off the coast of California so that our team can put electronic tags on the animals and figure out what regions of the ocean are most important for this particular species, if we think about it in a marine spatial planning context. So these tags have shown us, offshore regions like the White Shark Cafe, 1,000 miles from the coast, that were previously unknown, that we now know are quite important for this particular species, thanks to the work of Dr. Barbara Block and Sal Jorgensen and many other folks involved in that project. More recently, we've been tracking industrial fisheries so that we can ask similar kinds of questions, like fundamental questions about where these fisheries are operating, what kinds of gear types are being used in different places, and whether or not those patterns that we see are appropriately reflected in the marine spatial planning strategies that we're putting forward. Before I get into what some of those data sets look like, I should say that the newer data sets we've been developing, I certainly see as complements to the really important existing approaches and data sets that have been used for a good long time in marine spatial planning and in fisheries management, such as fisheries observers, which this picture on the left here is me as a fisheries observer in much beardier, saltier days than right now, where I was recording the catch and bycatch of crab vessels off the coast of Alaska. So from that experience and from other experiences, I know that fisheries observers produce really awesome, really valuable data sets, but that there's challenges globally with accessing that data if you do not have if you don't have access to that data, since it's often restricted by governments, or there's also challenges in global coverage in that many fisheries don't have fisheries observers on board. So the data sets we're developing are meant to kind of fill some of those holes and complement existing data sets. One of those approaches we've been using is tracking boats using the Automatic Identification System, or AIS. This is a type of electronic transponder that vessels transmit to help avoid colliding with each other at sea. So you can see on a little screen the other boats around you that are transmitting AIS. It is voluntary for some boats, it's mandatory for others, it depends on the vessel size and the country, but in general, at a global level, AIS can detect around 50 to 75% of the large industrial vessels that are operating offshore, but a very low percentage of the small-scale coastal vessels. So like any data set, it is the right tool for some questions, but for other questions, it can't provide much insight. So with satellites now recording the tracks of these vessels, since a lot of them have been launched in the last few years, we can build machine learning models that can separate out transiting behavior, where the vessel is just going from port to the fishing grounds, from the actual fishing activity, where from the track you can see changes in the vessel's course and speed, and then infer that it's fishing. Here's one example of what that looks like. This is a vessel track throughout time, where we are looking at a longliner go from various fishing grounds and set its gear there. Besides seeing where the vessel is fishing, I think it is really interesting that you can also detect, using these machine learning models, what specific fishing gear the vessel is using from its track alone, with pretty high confidence, so 90-ish to 95-ish%, depending on the gear type. Because, as you can see here, trawlers, longliners, purse seiners, and other gear types have quite different tracks based on the pattern they have to use to set and retrieve gear. So zooming out, we have ingested thousands and thousands of tracks from vessels from these satellites for a period of time starting in 2012 and produced in a paper that David Kreutzmann led a few years ago, this first global view of fishing activity as detected by AIS. So this was some of the, this kind of allowed us to demonstrate some of the techniques that we think would be valuable for ingesting and processing this information. And next, I'll get into a few quick examples of how having this really high resolution data, high resolution in terms of both space and time, so like daily info down to kilometer scale or less, how that really fine scale info can be used to help inform some marine spatial planning decisions. And before that, I'll just quickly say that in addition to the scientific papers, we believe very strongly that it's in addition to the papers, it's really helpful to release this information publicly. So if anyone's interested in either downloading data on global fisheries, understanding that it applies to industrial vessels, or playing around with the map and looking at the tracks of individual vessels, feel free to go to our website where you can download it or play around with it for free. Or email me if you have any questions about that. So the first quick example of how this information I feel has been useful for interpreting some marine spatial planning questions relates to large marine protected areas in the Pacific Ocean. Specifically, as you can see here, specifically motivated by the fact that some large United States marine protected areas have recently been under review for potential elimination or for reducing the size of these monuments, because there's currently some debate about whether or not the current size of the monuments is necessary, based on some uncertainties about what these monuments may be providing to fisheries and how providing to fish rather, and how they may be impacting fisheries. So in just one slide here, one example of how this high resolution info has been applied is that we tracked both gray reef sharks and industrial fisheries surrounding this MPA in question, so that we could provide a little bit of context on to what extent the large marine protected area is keeping fish and fisheries separate, and whether or not it may be advisable to change those boundaries. So in this figure here, the solid square that you see is the United States Marine Protected Area. It's part of the Pacific Remote Islands Marine National Monument. The dashed line going around that is the United States Exclusive Economic Zone, and the white dots are the movements of gray reef sharks that we figured out from some satellite tags. Finally, the color scale, ranging from the blue to the red, is a metric of fishing activity. So it's how many days we detected large industrial vessels fishing these waters. And with this little bit of science, we were able to kind of submit this as part of a docket of information that was used to interpret what impact removing this boundary or changing its boundaries may have. And our interpretation was that the monument is doing quite a good job at keeping fishing activity separate from fish, some of the intended species in this case, and that shrinking those boundaries may not be advisable if you want to keep those things separate. Another quick example zooms out a little bit and looks at the high seas. As many of us know, there's an increased focus on marine spatial planning in a high seas context. So I think that having this kind of information could be useful for guiding some of those decisions to be made as well. For one project, we mapped fisheries in a region of the Pacific Ocean by gear type, so we can see, for instance, where purse seiners targeting tunas are, where purse seiners targeting other things are, longliners, trawlers, produce those maps of fishing activity, and compare them with some predictions about where some species that we care about happen to be, based on years of telemetry data that's been collected and some habitat models built off of that telemetry data to understand, given a current set of environmental conditions, where do you think these fish may be? So by combining the fish with the ships, you can look at where you would predict overlap to be and how that may influence whether, say, a species is best served by national measures because of coastal patterns of overlap with fisheries, or whether high seas approaches may be necessary given high rates of international overlap with fisheries. Because with AIS signals, we're also able to link up the vessel to what specific country that vessel may be flagged to, and more information about the vessel's metadata. We can also look at how patterns of overlap with fisheries by nation vary across the predicted habitat of various species. So the hope is that this can provide, in addition to some of the existing official traditional data sets on fishing activities by nation, this can provide another touch of context on how different nations may be utilizing common space in different or similar ways. Finally, the examples I've talked about so far were somewhat academic, where the product was a paper and conversations with governments, but I also want to flag that another main focus that we have is these close analytical partnerships with governments and MCS agencies to help increase the amount and quality of free data on fishing activities, so that marine spatial planning decisions could be made with the best available data that can be produced, in addition to the data sets, of course, including, of course, the data sets that are already being used. So in a short bit of time, I'll just quickly mention that these are some of the data sets that I'm describing here. These are some of these data sets are available currently live now, ranging from fishing activity, which I've mentioned so far, to a vessel database where we compile information. We being used very royally here, where it's often someone smarter than myself, like a machine learning engineer who's doing this work. So take that with a grain of salt. So fishing effort, vessel database, information on ports and voyages, transshipment activity, where vessels are meeting at sea and potentially transferring catch, and some other data sets that are coming down the pipe. To close, just one quick example of how that may look is that these new data layers are actively being used by the US Coast Guard to help, as part of their overall information package, to help inform where they may want to guide their actual on-the-water patrols and resources. So that's to say that remotely sensed information can and actively is being used to complement other data sets to help actually guide patrols to do things like enforce the marine spatial planning measures that are actually put forward. With that, I will wrap up and just say, please feel free to contact me here if you have any questions, given that I'm definitely snoring right now. It's like 3 or 4 a.m. my time, and feel free to go to globalfishingwatch.org to play around with the map or to download the data sets and code. Thank you.